Welcome to day 2 of Next. I hope you had a good day yesterday and enjoyed the evening. We're here to talk about how you can build agentic AI applications with Gemini and developer platforms on GDC. My name is Rohan Grover. I'm the Senior Director of Product for Google Distributed Cloud, and I'm joined here today by Sridevi Ravuri, who is our Vice President of Engineering, and we'll be talking about all of the innovations that we've brought to our Google Distributed Cloud platform. We have a packed agenda today, and our focus is going to be on agentic AI and how developers can use the innovations that we bring to this platform, really build AI applications. We'll also talk about some very cool innovations that the engineering team has built, including models, AI infrastructure platforms, and AI inferencing platforms. So with that, let's get started. So you've heard about generative AI for the last 2 years, and I'm sure you've heard about it a lot just in the last day. But the reality is that as much as the generative AI revolution is ongoing, 50% of critical enterprise applications still live outside of the public cloud. And there are many sovereign organizations that want to take part in this generative AI revolution, but are locked out because of compliance reasons and sovereignty reasons. And there was a choice to be made between sovereignty and innovation. And I'm here to tell you that the choice between sovereignty and innovation ends today. Right? With the innovations that we are bringing to GDC, we are going to prove that sovereign AI and innovation can go hand in hand. Let's start with what are we solving for? The primary workload that we believe on GDC is inferencing. While there are many organizations that are still looking at training foundational models, talking to our customers, that's not what we are trying to do. We want to make Google Distributed Cloud the best platform to run inferencing workloads. And as we've talked to many of our customers, both in public sector and in regulated enterprises, we have heard about a few requirements for inferencing. The first requirement that we hear about is all about data and data integration. Many of these sovereign organizations have data that is spread across many different places. Their data corpus is unstructured and fragmented, and we have to figure out how to deal with that. The second big issue, these are regulated organizations, public sector, enterprise. It is all about governance, security, and compliance, and that's really key. Everyone in these organizations wants to use AI, but they are bound because of regulatory reasons, and we have to overcome those challenges. Third, as with public cloud, we need to ensure that this is a performant platform. For an end user, what really matters is low latency. Right? When I, as an end user, type a query in a large language model, I expect the response to come back in seconds. Right? And there are metrics like time to first token. We have to make sure that as we think of a solution to these problems, we are optimizing for performance and latency that is comparable to public cloud. Last but not least, we have to look at the total cost of ownership and make sure that you're getting value out of this buying decision that you're making. Let's double-click a little bit on the unstructured data problem. It is a fact that 90% of all enterprise data is unstructured, and that unstructured data is growing 3 times faster than structured data. And this unstructured data is multimodal. A lot of it is text, but it's also files, audio, video, pictures. And it's really hard for organizations to make sense of all this data. It is also a fact that less than 10% of this data is actually utilized by these organizations because they just don't know where everything is. So as we've talked to customers, we've identified 3 key use cases in sovereign AI that keep coming up all the time. The first use case, how do I search, summarize, and gather insights from this unstructured data that we just talked about? It's extremely difficult to do this. Data is in multiple silos, typically duplicated, and as we just discussed, these organizations cannot use the power of generative AI in the public cloud to make sense of this. So the first use case is really searching, summarizing data that is sitting in silos. Second use case is a related use case. It's also about the multi-language issues with data. Many organizations have data that is in multiple different languages. These may be public sector organizations, these may be enterprise organizations. A frequent use case we hear about, for example, are help desk chatbots. We have multinational companies that are trying to support their customers. Their customers come from many different countries. How do you build chatbots that can basically understand different languages, different dialects? This is also an issue with video and audio, and languages can be also contextual, right? What we understand in one language may be different in a different language. Now, both use case 1 and use case 2, there's one company in the world that's actually pretty good at solving search summarization. Google is great at many things, but what Google is really, really, really good at is solving these type of use cases. Okay. Use case 3 is about coding assistance. Developers around the world have been now using the power of generative AI to really innovate and increase productivity. Unfortunately, developers in regulated organizations have been left out of this revolution. My team, my engineering team, uses AI ourselves, whether it's vibe coding or others, and every developer wants to harness the power of AI. One frequent problem I hear from public sector and regulated enterprises is that as they look to hire the best and brightest talent, the best software engineers, they struggle because these engineers want to use AI, and they are unable to use AI because of these regulatory constraints. So how do we solve for these 3 key use cases? So you're all here. This is the GDC session, but I did want to talk for a couple of minutes on what GDC is. So GDC is part of our sovereign AI portfolio of solutions. It is our private and edge cloud solution. It is our premier AI inferencing platform on-prem. It is not just an AI inferencing platform. We also support a variety of different infrastructure and data services. This is the first platform that was built on a Kubernetes stack. Google invented Kubernetes. Google open sourced Kubernetes. And we took the decision 5 years ago to build this platform completely on Kubernetes. So it is the first cloud platform built on cloud-native technologies. From an operations standpoint, we are extremely flexible. This can be operated by Google, but for a lot of sovereign organizations, that's not an option. So we provide an option for a partner, a sovereign partner, to also operate this cloud, or as customers, you can operate this cloud yourself. From a deployment model perspective, this comes in 2 different form factors. We have a connected GDC form factor, where there is connectivity from a management plane standpoint. Data always remains on-prem. And then we have the fully air-gapped disconnected form factor, which is meant for the highest level of classifications, primarily in public sector and national security. Specifically, the air-gapped option has no kill switch. It can never be remotely shut down by Google because Google has no access to that system in the first place. So that's what GDC is. I'm very happy to announce a new reference architecture that we are calling the Google Distributed Cloud AI Engine. We believe this is going to be the catalyst for a new sovereign neo-cloud architecture. This follows many of the same principles of our public cloud, and the stack consists of AI infrastructure, compute, data, storage, and networking. We then have our foundational models, including Gemini, as well as other OSS and third-party models. I'll talk about the new set of inferencing capabilities that we're introducing, and then finally, applications and agents. And on the right side, you see an AI governance stack. That is equally important. How do we make sure that we can absolutely provide your workloads with the best security? So what we're announcing today is the availability of our latest and greatest Frontier Gemini 3 models on GDC, state-of-the-art AI infrastructure, including the Nvidia B300 GPUs on GDC, and a fully managed AI gateway with optimized inference, performance, and security. So with that, I'm going to pass this on to my colleague, who is going to walk you through the rest of the session.
Thank you, Rohan. Thanks, guys. All right, so I think as Rohan mentioned, we are bringing the state-of-the-art models, infra, and the AI inference platform. So let's dig into a little bit more detail around this. The first one is the Gemini 3 models. I hope some of you have tried that on the public cloud. When we are using it in our developer platforms and dev AI, it's night and day, right? So there are three big things that are, I think, useful for this market. The first one is the high performance and low latency. The third bullet is actually important. It's efficient processing with 30% fewer token usage. This is important, right? Like I knew the cost of the tokens, etc. So you can do the same performance with 30% tokens than compared to the Gemini 2.5 Pro. The long context. This is absolutely important for those coding tasks that Rohan mentioned, but also for all the video analytics. It can take 1 million tokens, and we are enabling that on GDC. What this means is you can basically upload your GitHub code and actually have it reason through it, and this is what we do today on the GDC side. But also, more importantly, you can have your video, audio, and text processed together, and that also is brought in with the multi-model capabilities. So the model is inherently multi-model, so you can put in these multiple input formats, and you don't have to do a lot of data processing in between, and so the friction for the data pipelines is reduced quite a bit. The other one for this industry is super important is the like lots of language support, right? 100 plus for input and output tokens. I was amazed at the demo that they showed at the keynote yesterday with the live translation to Spanish, etc. But then that is possible for 100 more languages here. Okay. In addition, in order to satisfy these use cases, we are constantly trying to match the public cloud availability of features. So some advanced features like deep thinking, structured output, function calling, etc. So these are on our roadmap. So the idea is, hey, that somebody is finding it useful on the public cloud, we need to bring it to the sovereign market. So we are trying to keep up with that, and that is the reason to support the same models and the inference stack on GDC. We talked about GDC. The main thing is about sovereign and data residency. And this is important for us. As Rohan mentioned, GDC actually is available in two different form factors. The first one is connected. This is where your data stays on-prem, the GPU servers are running on-prem, the model is running on-prem. But we can help you manage it from the cloud, like upgrades, monitoring, etc. We call that Gemini Connected. And here we make sure that we are monitoring, logging, we have attestation services, we can manage your model lifecycle in a secure, compliant way. The other one is what we call air-gapped. This is fully air-gapped, really targeted towards IL6 regulatory markets. Here we actually provide the entire operation stack for the operator to manage. Again, with the same strict security and compliance needs, in fact, much higher for the IL6 levels, with, again, monitoring, logging, model lifecycle, everything with the security and governance in place. So the big news today, the Blackwell GPUs on GDC, right? So this is state-of-the-art. We talked about the performance of the model, but the actual GPU architecture is what actually gives you that 30% inference performance improvement over the Nvidia B200. Some of the teams are actually running H200 on-prem. Now this is like a huge step up for us. So we're keeping up with the state of the art, and that is our plan, is to continue to evolve and bring in the latest GPUs to GDC. So let's talk about a little bit about the B300 architecture. It has, it's the Dell XE9780 servers with 1.5x high bandwidth memory than the B200s. It has basically, the reason we actually brought this in is between the 2.5 and 3.0, the model is much larger. So we should be able to fit that larger model onto one GPU server. And then as the model scales, the HBM, etc., should be enough in the model, in the GPU. So that was the main reason. And then so that we can actually fit in the larger models. This also provides us huge performance. So we talked about the latency. We measure that with the time to first token, time for the output token, etc. So these are all improved with the B300s. On the right-hand side, you see the 4 terabytes RAM. This is super important, right? So that it becomes actually the staging ground for all your data that can actually be hosted on the memory itself. The third point, confidential compute capable. And we'll talk about that a little bit. Why is that important for this stack? We are introducing these GPUs with 3 different VM form factors, the A3 Ultra, A4 High, and A4 Ultra. The A3 Ultra is aimed at the H200 VMs, and then the A4 High and the A4 Ultra, as you can see, is the B200 and the B300 form factors. Again, each of them highly customized for that GPU form factor and certain kinds of workloads for the customer. We talked a little bit about the confidential compute. This is actually a major innovation on the GDC side, where initially it's intended to actually protect the Gemini weights. And we are the frontier model that is sitting on the customer side instead of in a Google data center. So how do we protect the Gemini weights in a highly secure way, and so you're comfortable and we are comfortable with hosting it on-prem. So we've actually worked with Intel and also Nvidia to bring in this game-changing confidential compute technology on-prem with the performance that we need for inference. So what this provides is, we talk about data at rest encryption at the storage layers. We talk about data in transit encryption with the networking layers. Here, we are talking about the data in use, where the data in your memory, in the VM, is actually encrypted. This provides us the capability of running Gemini in a secure way, but also for your data to be encrypted, in the memory. We talked about the compute side, but the inference is more than compute. The next thing is storage. So again, state-of-the-art infrastructure for storage. Talk about hot storage for the low latency data. We have the NVMe disk for providing for use with KV cache, vector databases, and the protocol is actually the parallel file system storage. These are both we are trying to introduce this year into GDC. But a lot of the data is also stored on the cold storage for archival and also just kind of loading your models from the storage for redundancy, security, etc. We are actually increasing that performance as well. So the block storage performance has been raised to 30 IOPS, and we are increasing the scale of the object storage to 5,000 buckets per organization and 8 petabytes of total capacity for org. So compute and storage. Then we are adding a number of the data layer capabilities. These are needed to build any kind of end-to-end inference workload. You're developing a RAG system or your own search or summarization or a chatbot. So you need a vector database, and so we are providing a managed leading vector database from GCP, which is the AlloyDB Omni on GDC. We are also working with the data teams to provide the Spanner Omni as a user runnable service. So this is self-managed on GDC. And you can also bring your own third-party databases because GDC is actually a general purpose architecture with all of the VMs that we talked about. So compute, storage, data, now networking, right? So again, we have AI-optimized networking. This is state-of-the-art with providing the RDMA networking. There are 2 reasons that we need networking, right? The front-end networking, this is up to 1.6 Tbps and encryption in transit, as we talked about. The back-end networking, up to 1.6 terabits per second and encryption in transit, but hardware ready for RDMA. This is critical for those very high throughput, low latency inference workloads. And the hardware is also capable, and we plan to use that later, is to do GPU direct storage. All right, so now I'll bring Rohan back on stage to talk about the inference platform and also show us an exciting demo.
Thank you, Sridevi. So we talked a lot about AI infrastructure and models, and now I want to talk about additional innovations on the AI inferencing platform. So what is the problem here? The problem here is, as customers, you have choice to pick the models that you want. Now that you have Gemini as part of that choice, you can use Gemini 2.5, you can use Gemini 3, you can use Gemma 4. You can also use open models like Llama. So it's a problem for customers to figure out what is the right model, and even more of a problem to pick the right GPU to run the model. It is bespoke networks with highly complicated load balancing required to make sure you're getting the most out of your AI infrastructure. As you can imagine, GPUs are easily the most expensive infrastructure that anyone is deploying today in a data center, and we want to make sure you get the most out of this infrastructure. So we are announcing an inference service with AI gateway. What does this mean? So whether you are a client, a human client, a workload, or an agent, our AI gateway, which is a fully managed service on GDC, will basically do body-based routing and ensure that we are taking you to the right model to run whatever application that you have. Typically, it is the application that decides what is the most optimal model, and within the application, there's also a choice of a primary and secondary model. So the AI gateway can intercept the body of that query and make sure that it goes to the right model. Now, as part of an AI factory, you will have multiple AI farms that are running different AI models. So the first step in this AI load balancer is to take you to the right AI farm that is running the right model. Within that AI farm, now you will have many different GPU servers. Within those servers, you have many different GPUs. So the AI gateway has to ensure that it is picking the right GPU. And how does it do that? If you focus on the right side of this picture, once it has picked the right model, whether it's Gemini or OSS, within the set of available GPU servers, it looks at the KV cache utilization of those individual servers and GPUs. It looks at the queue depth and effectively picks the right GPU so that we have utilization across all GPUs. This is a fundamental problem because in many cases, based on the flow, you may end up picking the same GPU all the time, which means you have certain GPUs that are at 90% utilization and other GPUs at 10% utilization. With the AI gateway, we can ensure that you have a consistent utilization pattern across all your GPUs, and you will get the performance and cost benefits. GPUs are a scarce resource even in public cloud, more so on-prem. And getting the most out of this, we believe, based on public cloud data, will save you between 40 to 60% in terms of cost and increase your performance. Okay, so we talked about AI infrastructure, we talked about Gemini models, we talked about our new AI inferencing platform. I want to now shift gears and talk about agentic AI applications. So, agentic AI workloads are being enabled on GDC using a third-party ecosystem. We heard today, or yesterday rather, at the keynote session a lot about agent platforms and agent builders and AI gateways. We intend to provide that same functionality with a third-party ecosystem using a partner called K-Agent. This architecture of agent builder platforms, agent gateway, agent runtime is a reference architecture that we have worked on with K-Agent. This demo specifically is running in our GDC booth at the show floor, and we would highly encourage you to look at this demo so that you see how easy it is to build an entire agentic AI development platform based on K-Agent and NemoClaw on GDC. Okay, so we talked a lot about all the different individual components. I want to try to make this real now by talking about one use case. We picked use case 3, which is the coding assistant use case. And I'm going to talk about what the problem is. While we have anonymized the names of the customer here, this is an actual real customer use case and problem. And we'll talk about what the problem is and how, with GDC, we've been able to architect a solution. So this is a large semiconductor company, Apex Silicon. Semiconductor is a regulated enterprise. They have strict rules on what data can and cannot live in public cloud. These folks do a lot of fine-tuning on their semiconductor yields and waveforms, and they have this legacy application, hypothetically named WaveAlign, built in the mid-2000s. It was built using the technologies at the time, TCL and Perl, and it is going to require a lot of work, money, and effort to actually modernize this code base and bring it up to modern security standards as well as modern architectures like Python. There's also a ton of proprietary data here. This is clearly a regulated industry, and they have decades worth of data as well as historical simulation data that they have to make sure remains on-prem and completely secure. They did an analysis, and they realized that this is probably a 12 to 18-month project. If they were to do this in the traditional way, you would have a team of developers start doing the scoping and go through all of the processes that software development goes through. They can't use public cloud for this. If they could, this would probably be way simpler, but they simply can't. So you have these frustrated developers, senior management that wants this done in a few weeks, but it just can't be done given the limitations of on-prem systems today. So what we're going to talk about is how we can use all of the things that I just talked about on GDC and really take your existing on-prem code repository, your existing on-prem data sources, bring all of that into GDC, use Gemini and our overall GDC AI engine, and completely revector the application to be a modern application. So with that, I'm going to run through a demo. And let me just move here. So this is an application. This is not something that I am familiar with. I'm not an expert here, but you can see it's comparing waveforms and doing lots of very complicated semiconductor stuff. They're running tests, they're running failure scenarios. It's not a very friendly UI application, and it's just not the best way to run in 2026. These trial runs take a whole lot of time. Also, for refactoring applications, it is going to be extremely difficult. So we'll see what it's doing, and then we'll see how we can actually make this better as we go to Gemini. So first thing we're going to prove is...
But wait, Rohan.
Yeah.
You just said that we need to be on-prem.
Yes.
How do we know that this is actually running on-prem? And
well,
it doesn't have the public...
You can't ping the internet. The Gemini endpoint is completely local. You can see the URL says inference.gdc.internal. Right? So this is all running on-prem. So that's how we prove that this is really running on-prem without any connectivity. We are giving it a prompt. You can see we are giving a Gemini prompt that says, analyze this code base for vulnerabilities, provide a modernization plan to Python, and then save this in a recommendation file. So it's looked at the code base. It is now analyzing the code base for vulnerabilities and building a plan. It found 220 files in this code base. That's roughly about 27,000 lines of code. Because of Gemini's reasoning capabilities, it can actually do all this in a single context because of that 1 million context window. It is actually now doing a lot of the refactoring that we talked about. These are the recommendations that Gemini is giving me. And now, based on these recommendations, I'm actually telling Gemini, please go ahead and start actually implementing these recommendations, fixing the vulnerabilities, modernizing the code to Python, and doing a few other cool things that you will see. So now it started the modernization process, and it's going to go through this, implementing the instructions in the modernization code. Now, clearly, this demo is a speeded up demo. The reality, though, is for this code base, which is roughly 20 to 30,000 lines of code, this is typically a few hours worth of work. The difference between a few hours versus the 12 to 18 months that they had initially projected is phenomenally huge.
And I was thinking, being the engineering lead,
yes,
I think it's very hard to find someone who actually knows Perl and Tickle these days,
agree.
And to maintain it. So I'm super glad to see that Gemini can understand that code.
And you can see it's completely refactored the code. It looks way more modern. It's doing the same tests that it was doing before. It's doing it in a better architecture. It has fixed the security vulnerabilities that it found. And it actually inserted Gemini within the application itself. So Gemini is now part of the application as an advisor to actually implement recommendations in the application. Right? And again, this is a few hours. Now, clearly, there will be a few more tweaks. It is not a single prompt that you may need to do. This is obviously a demo. But literally, we are talking about a difference of 12 to 18 months versus a few hours. Now, many applications may be longer than 20,000 lines of code. But the point here is we can really simplify development lifecycle on-prem and enable them to use the best of cloud and AI technologies without compromising on security. And Sridevi, as an engineering leader, you are very familiar with the challenges. So we'd love to get your perspective. How does your team use applications like this?
Yeah, I have my team, some of my team sitting here. I think this is something that we are actually looking at every day, right? It has actually been game-changing to use Gen AI in our own development processes. First, like you called out, Rohan, these days whoever is graduating from college to actually get the right developers in, who are actually excited about working on your product, you need to be using the latest technologies and have them access to these models and also the IDEs that are actually capable of the Gen AI. I was talking to one of the regulatory customers yesterday, and he was saying that, hey, our developers are so used to, they have to come to the office, log in via a VPN, and then only being able to do it, and they're stuck with these very old interfaces, the Perl and Tickle. I think that's from my college days, which I'm not going to date myself, right? But I think and then he was like, how do I attract the latest developers? People who are actually excited about working on the code, and then we show them this. They think this is actually game-changing. And we see that all the time in our own development lifecycle. So I'm really excited that this will actually improve, first, the developer lifecycle, but also bringing the applications to actually use the data that they had. I think that was your main point earlier, is also a lot of the data that is needed to make these applications useful is actually stuck in this dark, what they call the dark data, unstructured, videos, audios, text files. So by applying Gen AI for both the coding, but also to actually leverage the insights from the data, I think will be a powerful message.
Awesome. So with that, let's take this home. We just talked about the benefits of a sovereign agentic approach to code development. We can really speed up innovation. We don't have to make a choice between sovereignty and innovation anymore. And we are hoping that this community of folks who are working for sovereign organizations can really take benefit of all of the innovations that the GDC team is bringing to the table. So key takeaways, GDC is a complete end-to-end platform that will meet all of your AI needs while ensuring security and sovereign compliance requirements. GDC today is the only option in the market to run cutting-edge frontier AI models like Gemini 3 Flash in your on-prem environment. The model is on-prem, your data is on-prem, all your data sources are on-prem, and none of that data will ever leave your premises, whether that's GDC connected or GDC air-gapped. It is scalable. With our AI infrastructure capabilities, you can start small. You don't have to invest and buy dozens or hundreds of GPU servers. You can start small with a couple of GPU servers, start innovating with our AI infrastructure, and then as you see the value in GDC, you can scale this out to meet the demands of your organization. So we have a number of sessions following this as well. We also have our blog post that talks about this. So thank you for being here, and thank you for your time.
Thank you.